Okay, so now we'll take a look at stack data structure. So let's imagine numbers that we will insert in the stack. We insert them by using the push method. First, we can insert number 1. Then we can insert any other element, let's say number 7. And we keep doing the push operation. The next element must be on top of the element that was inserted before. That's the property of the stack. And then if we want to remove elements from the stack, we will use the pop method. So when applying it, we must remove the element that is on top of the stack, in this case number 3. And we can keep popping elements from the stack. Next one will be the element on the top again. Now in this case number 7. And so on until there are no elements left in the stack. And now if we try to remove more elements from the stack, we will get an error because there will be an empty method that tells us there are no more elements in this stack. So after analyzing the functioning of the stack data structure, the vector stack in this case, we can see that it is a FIFO data structure. I mean, first in, first out. This refers to the fact that every element that we wish to insert in it, we must put it on top. I mean, the first in will be on top, and each element that we wish to remove from it, we must remove it from the top. So first out. And in terms of time complexity analysis, we can say that both operations push and pop are constant time complexity. And this is because we're always getting the element on top, and we can use a constant time to do it. So now taking a look at the code of the stack in the Python code, we can see that the data structure is referred to as a class stack here. There's the initializing method, which attributes an empty vector to the stack. Then there's the implementation of all the methods related to the stack. First, the push method, which inserts the element on the top of the stack. Then the pop method, removing the element from the top and returning as well. The top method, which simply returns the element on the top of the stack without removing it. The clear method, which empties the stack, removes all the elements in it. The size method, which verifies the quantity of elements that are in the stack. And the isEmpty method, which returns true the stack is empty or false otherwise. An example usage: first we need to instantiate the class stack in myStack object. So then we can use this object and call method push, and the argument number 1. For example, we are inserting number 1 in the stack, then we push number 3, 7, then we get the element on the top and we store in this variable. We pop the element on top, and store it in this variable. We verify if the stack is empty, and we store the boolean value in this variable. We get the size of the stack and store it in this variable as well. We use the clear method to remove all the elements in the stack.